All right, this is Monday, January 4th, 2021, Physics CP, beginning of electrostatics as a unit of study. To investigate electrostatics, what does it mean? So, statics means not moving, and electro is short for electricity. So, electricity that is not moving. The story begins with America's first scientist. Once upon a time, America's first scientist was petting his cat. And as he pet his cat, he noticed that the cat fur would rise up and he could hear, sparkly, snap, crackly, pop stuff. And he pondered that and he said, why is that? What happened when I pet the fur on my cat? And his speculation was that, oh man, I can't draw animals. Let's say, uh, that's a cat. This is why I'm not your art teacher. All right. And heck, I can't do his hand either. There's his hand. Thank you. Good. Again, why I'm not your art teacher. So after he pet the cat hair would stand up and be attracted to his hand. And the guy wondered, what happened that made this so? He imagined that there must have been something that was on the cat that he scraped off onto his hand. And after he scraped it off the cat, it wanted to get back onto the cat's fur. And that's why the cat's hair was standing up. And he could hear these little snap, crackly, poppy things going on all the time. And he said, oh, okay. So there's something. Now he looked at his hand and he couldn't see anything on his hand. Oh no, our 3-minute break right there. I'm going to pause this exciting recording. All right, just before break, I was talking about America's first scientist and how he decided he was going to study this stuff. He imagined that there was some invisible particles on his hand. He could call it whatever he wanted. He could say that this was green and that was yellow. This was up and that was down. He decided that because he liked his cat, whatever was on his cat, he called that positive, and whatever it was he pulled off onto his hand, he called that negative. So, of course, over 100 years later, when the electron was discovered, that's why we have you students learn that the charge on an electron is a negative charge, while the charge on a proton is a positive charge. I guess one question is, who was America's first scientist? Well, I could give you a hint and say he studied this stuff, and it's a long and interesting story. But I think right now, let me just start off by reviewing what you learned when you studied the periodic table, and you learned all about atoms. Yes, atoms. No doubt you remember that there are 3 main subatomic particles that you guys had to learn about in chemistry class. In fact, I could call on someone who's clinging to their bed sheet there. I could call on a random student. Hey, Nicholas N., what were the names of the 3 parts that make up an atom? Particles. Now that you've just joined us, Nicholas N.
Yes.
Name the 3 subatomic particles that make up an atom.
Neutrons, protons, and electrons?
That is absolutely correct. There's the neutrons, the protons, and the electrons. That's their name. The symbol for each one, the neutron was just a lowercase letter n. The proton was lowercase letter p. The electron was lowercase letter e, but we always wrote it with a superscript minus sign after the letter e. And I guess if you want to be a purist, you could put a plus sign after the proton, a zero superscript after the neutron. The mass of each one of these in atomic mass units for the neutron, it was 1. For the proton, it was 1. For the electron, it was 0. The mass of an electron isn't truly 0, but it's about 1 divided by 2,000th the mass of a neutron or proton. And so what we did in chemistry class is we rounded that off and said, oh, let's just call that 0. The part that we care about now in physics is the electric charge on each one of these particles. The neutron got its name because it has neutral electric charge. The proton has a positive charge. The electron has a negative electric charge. Now, even though the mass of a proton is close to 2,000 times greater than the mass of an electron, the electrical charge on a proton has the same magnitude as the electrical charge on an electron. When we think back to beloved chemistry class, we can remember that physically an atom has a nucleus. And here I could say, oh, I got 2 protons, 2 neutrons, so a helium nucleus. And then it's surrounded by an electron cloud, or I could just do a Bohr model and draw a little orbit going around it. My point is going to be this. The protons are stuck in the nucleus of an atom. They cannot be moved in or out of the nucleus by ordinary chemical means. The neutrons have no electric charge. And here we're trying to study not moving electricity. So we're going to be ignoring the neutrons pretty much throughout this unit. The only electric charge that can move are the electrons. They can be removed from an atom. They can be added to an atom. You might remember that after an atom has gained or lost an electron, it's called an ion. So electrons are the charge carriers. Oh man, imagine I'm trying to spell the word carrier, plural. Electrons are the charge carriers. They're the only ones that are going to be moving as we study electricity. No protons moving. Neutrons, we don't care. Even if they could move, they wouldn't make any difference. Only the electrons can be added or removed. And I don't care if you remember, but a cation is like this guy's cat, that is a positively charged ion. That means it has lost electrons. An anion is a negative ion, and that means it has gained electrons. And no, that's not onion. That's supposed to be anion. Anions, how I pronounce it. Cations, anions. Cations, positively charged ions. Okay. Of course, this being a physics course, we can put numbers to how much electric charge there is. And the number that measures amount of electrical charge is called the coulomb. This is the last name of a scientist who studied this stuff. Now, the way he came up with this is hard for you to understand right now, but it turns out, I'll just say this. I don't expect you to be able to, do this at home. And please don't try this at home. Mr. Coulomb took two wires that were parallel to each other, and he sent electrons moving down the wires, maybe even opposite directions. And what happens is moving electric charge creates a changing magnetic field. And so these became magnets that interacted with each other, and magnets can attract or repel each other. When they were exactly 1 meter apart and maybe 1 meter in length, when they had 1 Newton of magnetic force between them, he measured how many electrons went by in 1 second of time, and from that established how much 1 ampere of current is, and from that worked out what is 1 coulomb of charge. Wow. So, ignoring the history of how he came up with it, the amount of electricity on 1 electron has been measured to be negative, because it's a minus charge, thanks to America's first scientist, minus 1.602 times 10 to the negative 19th power coulombs. Coulomb is with a capital C. It almost looks like degrees Celsius to you, I know. But capital C is coulomb of charge. Coulomb of charge. The charge on a proton is exactly the same magnitude, but it's positive in sign. It's positive. 1.602 times 10 to the negative 19th power coulombs. Now, if I put that number into my calculator, actually, I want to check something on my calculator. Oh, okay. Ooh, let me check something else. So, coulomb, proton, no. Electron. Oh, wow. Here it is a semester later, and I still have the number in my calculator. 1.602 times 10 to the negative 19th. If I take the reciprocal of that number, that would mean 1 coulomb of charge is equal to the electric charge on 6.242 times 10 to the 18th power protons. 1 coulomb of electric charge is the amount of charge on billions of protons. In particular, 6.242 times 10 to the 18th power protons. Should make you feel like chemistry class again, where we deal with incredibly huge exponents, like a mole being 6.022 times 10 to the 23rd power. Well, this is starting to get up there towards 23rd power, right? It's 1/1,000,000th of a mole or so. 18, 90, 20. 1/100,000th of a mole, roughly. Okay. Let me keep going with my exciting educational introduction to electrostatics. Some of this stuff you should remember from middle school and elementary school. If I take a positive charge and I bring it near a positive charge, I could call on a random volunteer and ask, what will they do? Noah, C. What will they do?
They will. They will try and stay away from each other.
Exactly. They will try and stay away from each other. They will push each other apart. In fact, we would say they repel each other. So 2 positive charges will push each other apart. Now, separately, I don't mean this to be in the same neighborhood at all. Separately, what if I have 2 negative charges? What would they do? Or a bosa?
They will repel.
That is correct. They also push each other apart. They also repel. So based on the fact that positive charges repel and negative charges repel, we have you memorize like charges repel. Like meaning if they're both positive or if they're both negative, that's what we mean by like charges. All right. Well, that begs the question, a new sheet of paper. What happens if I have a positive charge and I bring it near a negative charge? Oh, Nicholas D. What saith thee?
They'll attract and come closer together.
That's true. They're going to try to attract each other. And so here we can say, unlike charges, attract. Or you could be like Paula Abdul, who in the 1980s released a song entitled Opposites Attract. He takes 2 steps forward, I take 1 step back. We're perfectly matched because opposites attract. You can watch the video at your own leisure. Okay, so there you go. This is the beginning of electrostatics. We have some physics unit to quantify how much electric charge we're talking about. Is it just 1 electron? Is it 1,000,000 electrons? Is it 10 gazillion protons? For each electron, it has this amount of electric charge. So some physics unit. The rules are, if they have the same electric charge, they're going to push each other away. If they are opposite electric charges, they're going to attract. Yikes. I still have 10 minutes, maybe 12. Let's see if I can do a page 2 here. So when we say that they repel or they attract, we're talking about a force here. Right? This is a force. F-O-R-C-E, force. Force. And that means, oh my goodness, this being a physics course, we can put an equation to this and units to this. All right, you guys love physics. You remember that there were 4 forces that we started off with. There was the force of gravity, equal to the weight of an object, its mass times gravity. There was the normal force, always perpendicular to the solid surface of contact. There was the applied force that could be in any direction. There's the force of friction, which is always opposite, not the applied force, please don't think that, always opposite the actual or attempted motion. Now, and of course we've had the net force, that's always going to be the sum of all the forces in our physics problem. And now I'm introducing you to the electrical force. Now, how should I write that one? Sometimes they do it with E for electrical. Sometimes they do it with C for Coulombic force. I'll go with an E. There is an equation for calculating it. Oh my goodness. The force of electrical attraction between any 2 objects is K Q1 Q2 divided by R squared. Whew! I'm pausing because in the old days, I would never introduce the equation on the first day. We would do hands-on experiments the first day. We would pull a piece of tape off a roll and see how it bends towards or away other objects. We'd have you guys inflate a balloon and rub it on your head and make your hair stand up, and then bring it near other objects and have you observe what happens. We would do all that before I would dump this on you. But here we are online. So I'm going to dump this on you and call this is called Coulomb's law. So it has a name. F is force, and its units are newtons, just like all the other forces are always in newtons. K has a name. I believe it's called Boltzmann's constant. It's not even called Coulomb's constant. It's called Boltzmann's constant. And its value is 8.99 times 10 to the 9th power newtons coulombs. maybe that's kilograms square. No, newtons, meters squared per coulomb squared. There we go. 8.99 times 10 to the ninth power newtons times meters squared divided by coulombs squared. Q1 is electric charge on object 1, and the units are coulombs. Q2, electric charge on object 2. R is distance from center of object 1 to center of object 2, and the units are meters. Oh boy. This suggests that I'm going to be giving you homework problems where you have to calculate based on this equation. Now, you might remember the way we've been doing things in this course is we'll give you some equation, like a kinematic equation, VF equals VI plus AT. And what we've done is we said, look, there's 1, 2, 3, 4 variables. We'll give you any 3 of them, and you have to solve for the last one. That's what we're going to be doing with every equation we ever give you in a physics course. So this equation has 1. This is a constant. That doesn't count. 2, 3, 4 variables. 1, 2, 3, 4 variables and a constant. So we're going to give you problems where we give you any 3 of these, and you have to rearrange the equation and solve for the one unknown variable. Right now, I'm going to close out with a practice problem. Suppose I have, a student that I call on. And I say, I have a bunch of either electrons or protons. How many of which kind? Gerardo. Give me some random number of either protons or electrons.
48.
And which kind?
Electrons.
Okay. Now, Xander, give me some other random number of protons or electrons.
48 protons.
Not the same number, child. You have the entire universe to pick.
49 protons.
Wow. And finally, Kevin, some random distance between the two of them. Hurry. 3 meters. Okay. So I'm going to tell you the force between them is incredibly tiny. The force between them would be 8.99 times 10 to the ninth power, which seems pretty big, times 48 electrons, but each electron is just negative 1.602 times 10 to the negative 19th power. So that's a tiny number, times 49 protons, but each proton is just positive 1.602 times 10 to the negative 19th coulombs. And the distance between them is 3 meters, and you're going to square that distance. So on my calculator, they're going to attract. That's what the minus sign means. The minus sign means attract, and I'm going to type this in now. 8.99 times 10 to the 9th times 48 times negative 1.602 times 10 to the negative 19th times 49 times positive 1.602 times 10 to the negative 19th divided by 3 squared. Enter. 6.03 times 10 to the negative 26th power newtons. That's how much electrical attraction there would be between 48 electrons and 49 protons that are 3 meters apart. Sometime this afternoon, I'll create a homework assignment and post it and make it due on Wednesday. This concludes our educational program for today.